We're now looking at the Unit 3 review. So we'll start with number 1. In number 1, we're looking to simplify. So the first thing I need to do is distribute the 2 and the 4 to their respective polynomials. So by using distributive property, I get 6x squared plus 12x for the first term, polynomial. Then 4x squared minus 12x, about 4 times that would be 48x minus 4. Now I need to combine like terms. I have x squareds, so that's 10x squared. I have 12x minus 48x, so that's negative 36x, and negative 4 is by itself. Since I am simplifying, I can just combine them here, and that's an acceptable answer. I could look for factors, but I'm not factoring. I'm just looking to simplify, combine like terms. For number 2, we use distributive property again. So I get 5/3 y times 3x. So that's going to be 5/3 times 3xy minus 5/3 times 30y. Before we go any further, let's simplify that. Well, 5/3 times 3 is just 5, so that's 5xy. And then 5/3 times 30, since it's really just almost like multiplying fractions here, I can reduce, and I get 50. So it'd be negative 50y. So it's going to be negative 50y minus the other polynomial. I like to distribute the negative, so I make that negative 8xy plus 12x minus 3y. Notice I changed the sign on all those terms. So now I combine like terms. I get negative 3xy with negative 8 and 5. I only have one x, so that's 12x. And it looks like negative 53y. Go down to number 3. Since it's multiplying terms, and I'm not adding any terms in it, and I don't have to look at multiplication, I'm really just multiplying the like terms together. So 3 times 2 is what I'm going to multiply, but I almost got ahead of myself there. I have to make sure I take care of this 3 as the exponent. So one of our rules for radicals is we almost distribute the exponents as we go through that. So that's going to be 2 to the third. X would be 2 times 3, and y to the third. So we get 8 x to the 6th, y to the third, and now that's times 3x to the 4th, y to the 5th. So it gives us 24, which is 3 times 8, x to the 10th, y to the 8th. When we have an exponent like we had for x, 2 to the x squared to the third, we multiply the exponents. But when we have terms where we're multiplying like bases, like we did in the second part, that's going to be where we actually add the exponents. Alright, number 4. We're going to take the same idea here. I have negative 8, negative x, and negative 5. Really, it's a negative 1 in that second one. So multiply those together, and it comes out to be a negative 40. Then I got x. Let's see, I got 2 x's, 3 x's, and then none, so that's going to be 5 total x's. I have y to the 4th, just one set of those. Z to the 5th, z to the 7th, so it will be z to the 12th. Okay, next screen, now we're going to square them. If I look at the second part here in number 5, that's going to be 4x squared y squared. That's different than the first part. In the first part, that's a binomial, so we're actually going to have to multiply with a binomial. And you have various methods. You could stack them vertically, you could use FOIL, and you could use the box method, which we'll look at soon on some of the other ones. But for this one, it's going to be 4x squared is our first term. Then we're going to have negative 4xy as our second term, and plus y squared as our third. We look at our terms, we can't combine any of them, so we just leave it as that, and we can move on. Number 6, let's look at the first two terms to start, and we'll distribute. We get 3x squared plus 21x, and now I'm going to multiply that by 5 minus 2x. Now this is a good point here to use the box method. So if I use the box method, I'm going to write each of them, 2 terms by 2 terms. I'm going to put each of them in a bigger box here. 3x squared plus 21x will be on the top side, and then 5 minus 2x will be on the left side. And really it's just multiplying a row times a column. 5 times 3x squared is 15x squared. 5 times 21x is 105x. Negative 2x times 3x squared is negative 6x to the third. And then negative 2x times 21x would be negative 42x squared. From here, we combine like terms. I have 15x squared and negative 42x, so those are like terms. It comes out to be negative 6x cubed, and then negative 42 and 15, that's going to be negative 27x squared plus 105x. Move this down a little bit. And there's our result. Okay, now we go over to number 7. We'll do the same thing here with the box method. Now it's just a 3, really a 3 by 2 is how I'm going to set it up. 3x minus 4 I'll put on the left side. 2x squared, x, and negative 1. And we just go through and multiply to fill in all the boxes. And now we can combine like terms. I have 6x cubed, that's by itself. I have a negative 8x squared and a 3x squared, so that's going to be negative 5x squared. Negative 4x, negative 3x is negative 7x, and plus 4. So there's our answer for number 7. Number 8. This time we'll use FOIL as we go through. And I'm going to first focus on these first two terms. So FOIL, I'm going to multiply the first terms. So that's x times x is x squared. I'm going to multiply the outside terms. That's x times negative 4 is negative 4x. The inside terms, which is 2 times x. And the last terms, which would be negative 8. What we're really doing here is multiplying every term in each binomial by the terms in the others. So x in the first one is being multiplied by both terms in the second one. 2 in the first term is being multiplied by the other terms, both terms in the second one. That's what FOIL is used for. That's what we need multiplication for. Same thing with the box method. We multiply each term in each binomial by the terms in the others. So I can combine like terms here. X squared minus 2x minus 8. And I can bring down that x minus 1. And now we'll try FOIL again and see if it works. Now we're not going to specifically do the f, o, I, and l. We're just going to try to multiply each term by the terms in the others. So I'm going to start with the x squared. X squared times all the terms in the other binomial, x minus 1, gives me x cubed minus 2x squared minus 8x. Now, I got ahead of myself. What did I do differently? Well, I actually multiplied this whole term, my first binomial, by x, which we'll just do that instead now that we've already started. But the key thing is I'm going to eventually going to multiply all the terms. So now I'm going to multiply everything by negative 1. So that's negative x squared plus 2x plus 8. Now I got to go through, be careful. This is one downside to using that FOIL or the horizontal way of writing it. Sometimes we miss the like terms. I like to just look at the exponents, and that kind of helps me group them. I get x cubed. That's taken care of. I have negative 2x squared, negative x squared. It's negative 3x squared. Negative 8x plus 2x gives me negative 6x, and I'm left with an 8. Now, number 9, we're going to multiply the 5 plus x and the x minus 8 first, and then we're going to add 4x to that. So if I multiply 5 by both terms, I get 5x minus 40. Now x by both terms, I get x squared minus 8x. We rewrite this in descending order. I get x squared minus 3x minus 40. Bring down the 4x. I'm going to add to that, so I get x squared plus x minus 40 as an answer. On number 10, we're looking at the volume of the rectangular solid, and 11 for that matter. And what we're going to do here is, if you remember, volume of a rectangular solid is you multiply all three dimensions. So it's really going to be x plus 3 times x minus 1 times x plus 2. So we'll multiply the first two together. I get x squared minus x, then 3x minus 3. So that comes out to be x squared plus 2x minus 3. I bring down the x plus 2, and we'll multiply x squared by both terms, x cubed plus 2x squared. Multiply the 2x by both terms, 2x squared plus 4x, and the negative 3 by both terms, negative 3x minus 6. So now I have x cubed plus 4x squared plus x minus 6. Same idea on number 11. I'm going to multiply the first two together. I get x squared minus 4x, then plus x minus 4. This combines to be x squared minus 3x minus 4. I bring down the x plus 3. Now the x times both terms gives me x cubed plus 3x squared. Then the negative 3x times both terms gives me negative 3x squared minus 9x. And last we get negative 4x minus 12. Combine my terms, x cubed, well, 3x squared, negative 3x squared becomes 0, so I don't need that. Minus 9x and 4x is negative 13x minus 12. And there's my solution for that one. Now we're looking at number 12. Number 12, we're going to focus on the numerator and denominator separately and then put them together. So if I look at the top, I'm going to distribute. We want to think of that 3 as the exponent. So that's going to give me 3 to the third, x to the third, and if I have y to the third, I really have 9y, so that's y to the 9th. On the bottom, I have negative x squared. That's going to actually become positive. If I think of negative 1 squared, that's positive 1. Let's write a 1 there. I get x to the 4th, y to the 6th. Now, 3 to the third is 27, so that's going to stay up on the top. I have x to the third and I have x to the 4th on the bottom. I have one more x on the bottom, so it reduces to just be an x on the bottom. I have y to the 9th on top, y to the 6th on the bottom. I have 3 more y's on top, so it's going to be y to the 3rd on top. For number 13, I'm going to simplify each of the separate terms, then multiply them together. Negative 5 squared is 25. A squared squared is a to the 4th. For the bottom, we get 16b squared. We multiply that, I get negative b to the 3rd, and that stays as a negative because negative 1 cubed is negative 1. And then we get 8a to the 3rd. Now we're going to multiply across. So I have negative 25 a to the 4th, b to the 3rd. And then 8 times 16 is 128. A to the 3rd, b squared. And now we can simplify a and b. Since I have one more a on top, it will stay on top. One more b on top, that'll stay on top. So it reduces to be negative 25 AB over 128. Number 14, I'm going to distribute it again, and I get 3 to the negative 3rd, x to the negative 3rd. That would be, if we think of negative exponents, that means we need to put it underneath the fraction. So it would be 1 over 3 cubed, x cubed, and then 3 cubed is, of course, 27. So we write as 1 over 27x cubed. Number 15, we need to be careful because it's very close to 14, but the 2 does not have the negative exponent. So I would actually just move the x underneath, so it would become 2 over x to the 4th. Different thing than 14. You got to pay attention to those parentheses. 16, I'm going to distribute that 2 as the exponent. I get x to the negative 2, 6 squared, x to the negative 6. We could make sorting a little bit easier and switch the negative 2 and 6. Think of moving them respectively in their positions, and I get x to the 6th, x squared, and then 36. And I have to simplify the x's, and since I have 4 more on top, it'll be x to the 4th over 36. You could have also used the property that when you divide like bases, you subtract the exponents, so it would have been x to the negative 2 minus negative 6, which does come out to be x to the 4th, and that would have also worked in this case. 17, I get 2 to the negative 2. You know what, before we get ahead of this, each of these terms, let's write it as this, is going to have a negative 2, both the numerator and the denominator. So instead of taking that negative 2 and distributing it, why don't we flip it first and write it as x squared y to the negative 3 squared over 2x to the 0 squared. Now we can kind of work with it, and we've taken care of the negatives. So I get x to the 4th, y to the negative 6th, and on the bottom I get 4, it's 2 squared. Now x to the 0 squared. I'll multiply an exponent, so that's still going to be x to the 0, which turns out to be 1. So all we're left with here is x to the 4th stays on top, y to the negative 6th moves down, so it's x to the 4th over 4y to the 6th. 18, I get 2 to the 3rd, x to the negative 9th, y to the 6th. Then on the bottom I get 4 to the 3rd, x to the 12th, y to the negative 12th. So let's see. 4 to the 3rd is actually 2 squared to the 3rd. So we could actually rewrite this as 2 to the 6th. And if we did that, we'd be left with 2 to the 3rd on the bottom, because we'd have 3 more on the bottom. So I'm going to put that down there. Now, x to the negative 9th is going to be moved down. It's going to actually move down with the 12, so I'm going to end up with x to the 21 on bottom. And even that y to the negative 12 on the bottom is going to move up to with the 6, so I'm going to have y to the 18th on top. I actually get y to the 18th over 2, oops, got ahead of myself, 2 to the 3rd, x to the 21. We can simplify that further. That's y to the 18th over 8, x to the 21. Number 19, we're given the volume, and the height of the solid is x units. We need to find the length and the width. So what we can do here is actually we can factor out an x, and this is going to make this problem a little bit nicer. If I factor out an x, I get 3x squared minus 13x minus 10. So if we look at the product of the length and the width, it would be this value, because it's length times width times height. Well, the height's x, that's out. We need to now factor that down, and maybe we can find the possible values. And if we look to factor it, I'm going to multiply the first and last term to get negative 30. So I'm looking how I can multiply to get negative 30, but those two terms add to negative 13. Well, what I can come up with is, well, negative 30 is negative 15 times 2, and then negative 15 plus 2 is negative 13. So I'm going to break that up to be 3x squared minus 15x plus 2 minus 10. And where I got that from is I just took the negative 13 and wrote it as two terms. And now I can factor by grouping, which would be take out a 3, x to the first two terms. I'm left with x minus 5. In the second term, I take out a 2. I'm left with x minus 5. I combine, well, I factor out an x minus 5, actually. So I get x minus 5. That's out. and I'm left with 3x plus 2. Those are each possible values for the length and the width. Now, for the next one, we're given the height is 2x. We're going to do the same thing. We're going to factor out a 2x. Leaves me with 4x squared minus 4x minus 3. Same process here. I'm looking to what I can multiply to get negative 12 that adds to negative 4. I could do negative 6 times 2, and that still adds up to negative 4. So that's going to be 4x squared minus 6x plus 2x minus 3. I can factor out at 2x. I can only factor out a 1, really, in the second one. But they have 2x minus 3 in common. I take that out, and I'm left with 2x plus 1. And those are my possible values for the height and the width, or the length and the width, we should say. All right, move on to 21, and now we're looking at division. I think it's time to change colors. So we're focused on the front term, that x, and multiply it to see how we can get to the leading term inside the division. So if I had an x and I wanted 3x squared, I would need to multiply that by 3x, because that would give me 3x squared, and then the second term would be 6x. But when we do division, like when we do long division with just numbers, we then subtract that. So that's gone. The first term's gone. I'm left with 2x, and I can bring down the 7 plus 7. Now, what would I do to x to get 2x? Well, I'd multiply by 2. So that gives me 2x plus 4, but we subtract it, so the first term is gone. I'm left with 3, so my remainder is going to be 3 over x plus 2. Now we move on to 22. I have 2x and I want 4x cubed. I'm going to multiply it by 2x squared to get 4x cubed minus 2x squared. It's division. Subtract, change the signs. First term's gone. 8x squared minus 2x. Let's use 4x. So I get 8x squared minus 4x. Change the signs because it is subtraction. I'm left with 2x plus 3. So I'm going to multiply by 1. I get 2x plus 3, or 2x minus 1. I subtract, change the signs. I'm left over with a 4. So my remainder is going to be 4 over 2x minus 1. All right, let's look at some more division. 3x minus 6. I'm going to multiply by an x to the third. Subtract. 18x cubed plus 9x squared. Let's do now 6x squared. So I get 18x cubed minus 36x squared. Change the signs. 45x squared plus 3x. Let's see, now we're going to go 15x. So that'll be 45x squared. 6 times 15 is 90 minus 90x. I'm left with negative 87x plus 10. So we're going to finish up with here, we have 87 and 3. To multiply 3 to get 87, we would have to do 29. So it would be 29 will be our last value. So we get 87, that would be a negative 29. Negative 87x, and then 29 times 6 is 174. change our signs. We get negative 164 as our remainder. So our remainder is negative 164 over 3x minus 6. Now before we start 24, we have to notice that we don't have all of our terms on our x squared minus 3. So I'm going to rewrite this as x squared plus 0x minus 3. And that's going to just help us hold the place value. 2x to the fourth plus 5x to the third minus 8x squared minus 15x plus 6. Alright, so we start with our first term, 2x to the fourth. Let's do a 2x squared to that. 2x to the fourth. Now the middle term is 0, so we don't need to put it in. Minus 6x squared. Change our signs. I bring down a 5x cubed minus 2x squared minus 15x. Next I'm going to multiply by 5x. So I get 5x cubed. Middle term, there's nothing there. Plus 5, about negative 15x. Change the signs. That's gone. In fact, the negative 15x is gone. So negative 2x squared plus 6 is all I'm left with. Let's go with a negative 2. I get negative 2x squared plus 6. Change the signs, and they actually becomes out to be 0. So this one we have no remainder. It's 2x squared plus 5x minus 2. Now we go to some factoring. So, number 25, good thing to start with is if they have a common factor, factor that out first. And they both have a 9 in common. I take that out. I'm left with x squared minus 1. This is difference of two squares, so it becomes x minus 1, x plus 1. If I didn't do the 9 in the beginning, I would have to still factor it out. You may end up something like 3x minus 3 and 3x plus 3. You still have to factor all the way out. So it's 9 times x minus 1 times x plus 1. 26. 26 we can't factor. That's not going to be a difference of two squares. We don't have a sum of two squares, so this one is completely factored. Does not factor anymore. We're done with that one. Now that's different than 27. 27 is a sum of two cubes, and this is one where we have the rule where our term a cubed plus b cubed results in those two factors. So a is x, b is 3, because that's 3 cubed is 27. So my answer is going to be x plus 3, x squared minus 3x plus 9. And that's pretty much a rule you just got to memorize, and that's the sum of two cubes, and when we have the difference of two cubes, which is next, and if we look at this one, it's really 2x cubed minus 5 cubed. Now the only way this is different is for difference of two cubes, we change the signs, so it's going to be a minus b, a squared plus ab plus b squared. And we talked about this one before where we have the same sign, the opposite sign, and always positive. The a's, the b's, those stay in the same place, but when it's difference of two cubes, sum of two cubes, those sign places change. So we get 2x minus 5. Then that'll be 4x squared plus 10x plus 25. We go to 29. I have x to the fourth minus 16. Now remember, x to the fourth is really x squared, and 16 is 4 squared. So this is the difference of two squares that we could write as x squared minus 4, x squared plus 4. But we're not done yet, because we can actually simplify the first one more, because that is still the difference of two squares. That turns out to be x minus 2, x plus 2, which looks like number 25, really. but we do not simplify the second one. That's the sum. We can't simplify that, so that's just x squared plus 4. That's already factored. That's like number 26. Number 30, we have something in common in both, although it looks a little bit different. They both have c minus d in common. We take that out. We're left with x plus 3. So it's c minus d times x plus 3. 31, we're going to do factor by grouping. So I'm going to take each set of two terms, I'm going to factor out what they have in common, and if those factors are the same, I can group it. So the first two terms have y in common. That leaves me with x minus 2. The other two terms have a 2 in common. That leaves me with x minus 2. So I'm going to take x minus 2 out of both of those, and I'm left with y plus 2, and that's factored completely. 32 is our standard trinomial. We talked about these a little bit earlier when we looked at 19 and 20. I'm going to look at negative 24 to multiply, but it needs to add up to 10. So negative 24 multiplying to add to 10. Let's see, let's do positive 12 and negative 2. That adds up to 10. So it's going to be 8x squared, and remember I get the 12 and negative 2 from that 10x, plus 12x minus 2x minus 3. I'm going to factor out a 4x from my first two terms. Leaves me with 2x plus 3. I'm going to factor out a negative 1. Leaves me with a 2x plus 3. They both have 2x plus 3 in common. I take that out from both, and I'm left with 4x minus 1. 33, same idea. I have negative 12, but I want to add the negative 1. Looks like I'm going to pick negative 4 and positive 3. So I get 6x squared minus 4xy plus 3xy minus 2y squared. I can take out a 2x from my first two terms. Leaves me with 3x minus 2y. I can take out a y from my second two, leaves me with a 3x minus 2y. They both have 3x minus 2y in common. That comes out. I'm left with 2x plus y as my final factored answer. (34). I have 36, negative 12. To multiply to 36 to add to negative 12, what could we do? Well, 36 is 6 times 6, so we could do negative 6 and negative 6. We could try that out. So let's do 4x to the 4th minus 6x squared minus 6x squared plus 9. I can factor out a 2x squared here, and I get 2x squared minus 3. And I could factor out a negative 3 here, and I get 2x squared minus 3. They both have the same in common. So I'm going to take 2x minus 3, or 2x squared minus 3, 2x squared minus 3, and we actually notice they're the exact same thing. So we could even write this as 2x squared minus 3 squared. Okay, 35. I could look to start factoring with the difference of two squares, but they actually have 4 in common. So I could take out x squared minus 25y squared. And my difference of two squares leaves me with x minus 5y, x plus 5y. 36. Let's treat x plus 7 as just a term. So if you want to call it a or b or y or something, probably other than x would be good. If we look at it as just that, we can factor this in the form of whatever you call it, minus 6 and then plus 6. So we factored it down. Now we put x plus 7 back in, it fits, we can actually simplify. We get x plus 1 and x plus 13. What you don't want to do here is square x plus 7, then subtract 36, then try to factor it down. If you just think of that x plus 7 as a term by itself and use that to help you factor, then it lets you simplify it, put it back in, substitute it out, call it a blob, do whatever you need to, and then you can eventually get down to the simplified factored form. Same thing works on 37. Let's think of x plus 2 as just a blob. It's a blob squared plus 8 times a blob plus 7. And that blob is just our unknown, it's our variable. We don't want to think of it as x plus 2 yet in the context of the factoring on the big problem, but we'll put it back in when we need it. So if I'm going to factor that, it's going to be the blob plus 7 and the blob plus 1. Again, if you don't like blob, just make it a different variable other than x. So that's factored down. Now I put in x plus 2 back in. And I get x plus 9, x plus 3. Okay, 38. Looks like sum of two squares. My two squares are 4x, not squares, cubes. Try again. Be cubes. So it's going to be 4x, same sign, plus y. Then the squared, 16x squared, opposite sign, the product of the two, 4xy, always positive, y squared. 39, I have four terms. I look to factor by grouping. Let's see. The first two terms, I have an x cubed in common. That takes out, leaving me with a b plus c. Next two, I have a negative 9x in common. That leaves me with b plus c. So I get x cubed minus 9x times b plus c, but wait, I can keep factoring this. I can take an x out, and I'm left with x squared minus 9 bc, b plus c. I can keep factoring now because x squared minus 9 is actually a difference of two squares, x minus 3, x plus 3, b plus c. So keep factoring. That's a good example of why you got to keep factoring and looking to make sure you're done and it's factored completely. Number 40, same like 37, same like 36. Just think of that x minus 5 as a term. It's really a difference of two squares in the big picture. So it's, think of a blob minus y, blob plus y. Now we put the x minus 5 back in. You could write it as that, or you could even write it as x minus y plus 5. X plus y minus 5 as our answer. Oops, should have made that a negative down here. There we go. Okay, now we'll go to 41 and we look at our cubes. This is 27a cubed is actually 3a cubed minus 4b cubed. So it's a difference of two cubes. That's going to be 3a, same sign, minus 4b. Then the squared, 9a squared, opposite sign, product of the two, 12ab, plus an always positive squared, that's 16b squared. Last, we have 42 here. I'm going to find common factors. So I could probably start by trying to take out maybe a 2 and an x. If I take out a 2 and an x, I'm left with 16x squared minus 25y squared. Now it's going to be a difference of two squares where I have 4x minus 5y and 4x plus 5y. It's factored down completely, and I'm done.